Hello dear student, welcome to our new session of current electricity. It's your fifth lecture. In this lecture we'll discuss about a law which is basically backbone of this chapter, that is Kirchhoff's law. That is Kirchhoff's law. That is Kirchhoff's law. So, Kirchhoff's law. My dear student, Kirchhoff's law is of two types, or we can say Kirchhoff's can give two different laws. First law is considered to be Kirchhoff's first law and second law is said to be Kirchhoff's second law. So two laws are there, Kirchhoff's first law and Kirchhoff's second law. Now we'll discuss what actually Kirchhoff's first law is and what actually Kirchhoff's second law is. Remember my dear student, after discussing this law, further topics which is related to this chapter, that is current electricity, is basically based on this law as well. So try to understand this law very carefully. So Kirchhoff's is name of scientist. On his name, there are two laws. First is your Kirchhoff's first law and second it is Kirchhoff's second law. Now see my dear student, this first law is also called current law. First law is also called current law. First law is also called current law, or we can say Kirchhoff's current law, and in short form sometime we can write it as KCL. KCL means Kirchhoff's current law. KCL means Kirchhoff's current law. Next, this law is also called junction law. This law is also called junction law. So Kirchhoff's first law is also called junction law. I'll discuss what actually junction is next. This law is, my dear student, very important point, this law is based on conservation. This law is based on conservation of charge. See, basically this law is current law and we know that current is nothing but flow of charge with respect to time. That's why we'll say this law is based on conservation of charge, and we know about conservation of charge. Conservation of charge means charge can neither be created nor be destroyed. Charge can neither be created nor be destroyed, but can transfer from one body to another. So my dear student, remember this thing. This is all about Kirchhoff's first law. See, Kirchhoff's first law is also called Kirchhoff's current law. In short form, we can write this law as KCL. KCL means Kirchhoff's current law. This law is also called junction law. And my dear student, this law is based on conservation of charge. This is basically very important point, as Kirchhoff's current law, or we can say Kirchhoff's first law, is based on conservation of charge. And we all know about conservation of charge. Conservation of charge means charge can neither be created nor be destroyed, but can transfer from one body to another. Similarly, my dear student, let's talk about Kirchhoff's current law. This is basic idea of Kirchhoff's first law. After discussing second law basic form, we'll discuss in detail about Kirchhoff's first law and Kirchhoff's second law. So check it out, what actually Kirchhoff's second law is. So dear student, Kirchhoff's second law is also called voltage law. Kirchhoff's second law is also called voltage law, or we can say Kirchhoff's voltage law. So in short form, we can write this law as KVL. KVL means Kirchhoff's voltage law. KVL means Kirchhoff's voltage law. Similarly, first law is said to be junction law. Second law is said to be, my dear student, loop law. Second law is said to be loop law. As first law is said to be junction law, so second law is said to be loop law. Moving forward, this law is based on, first law is based on conservation of charge, but second law is based on conservation of energy. As we know that it is related to voltage, and voltage is basically in form of energy. We'll discuss this thing in chapter number 2. So voltage law. So this law, again very important point, this law is based on conservation of, this law is based on conservation of energy. This law is based on conservation of energy, and we all know about conservation of energy. It is energy can neither be created nor be destroyed. Energy can neither be created nor be destroyed, but can transfer in one form to another. But can transfer in one form to another. But can transfer in one form to another. I am repeating once again, my dear student. Kirchhoff's can gives two different laws. Kirchhoff's can gives two different laws. Kirchhoff's first law and Kirchhoff's second law. First law is also called current law. Similarly, second law is also called voltage law. First law is said to be KCL. KCL means Kirchhoff's current law, and second law is also said to be Kirchhoff's voltage law, KVL. First law is said to be junction law, and second law is said to be loop law. We'll discuss what actually junction is and what actually loop is. Now last point, this law is based on conservation of charge. Remember, my dear student, first law is based on conservation of charge, and second law is based on conservation of energy. First law is based on conservation of charge, and second law is based on conservation of energy. Now we all know that conservation of charge means charge can neither be created nor be destroyed, but can transfer from one body to another. Similarly, energy conservation means energy can neither be created nor be destroyed, but can transfer in one form to another. So this is all about Kirchhoff's first law and Kirchhoff's second law. Now we'll discuss in detail about what actually Kirchhoff's first law is and what actually Kirchhoff's second law is. So write down, my dear, heading Kirchhoff's first law. Write down heading Kirchhoff's first law. So write it down, Kirchhoff's first law. Kirchhoff's first law. So Kirchhoff's first law is also called Kirchhoff's current law, or we can say junction law. First of all, let's discuss what actually junction is, then we'll discuss what first law says. So write down first heading, it is Kirchhoff's current law. Kirchhoff's current law. I'm writing here Kirchhoff's first law. So Kirchhoff's first law is nothing but Kirchhoff's current law. Now as we know, this law is also called junction law. So first of all, what actually junction is, let's discuss about the term called junction, my dear student. So see, there is a point. At this point, let's suppose more than one wire is meeting. Let's suppose this is our first wire, this is our second wire, this is our third wire, and this is our fourth wire. So you will see here there is a point at which more than one wire is meeting. So we'll say this point is called junction. This point is called junction. So what junction means? Junction means meeting point of more than one wire. Meeting point of more than one wire is called dear student, junction. So remember this thing. If there is a point, at that point let's suppose more than one wire is meeting, so that point is said to be junction. So what actually junction is? Junction is nothing but meeting point of more than one wire is called junction. So basically this first law is nothing but also called as junction law. So this point is called junction because at this point 1, 2, 3, 4, that means more than one wire is meeting. So we'll say this point is called junction. Moving forward, let's discuss what actually first law says. So first law says, let's suppose we have a junction like this. So we have a junction, and let's suppose junction means more than one wire is there. So let's suppose we have a junction. Let's suppose we have a junction like this. So this is a point. This point is called junction. 1, 2, 3, 4, 5. Let's suppose 5 wire is meeting at this point. So this point is called junction. Now see my dear student, there is two new terms. One is your input current. And second is your output current. So first is your input current and second is your output current. We'll discuss about what actually input current is and what actually output current is. So see my dear student, let's suppose in this wire I1 current is going, in this wire I2 current is there, in this wire I3 current is there, in this wire I4 current is there, in this wire I5 current is there, and in this wire I6 current is there. So 6 wires are there in which different currents are present. In first wire the current is I1, second wire current is I2, I3, I4 and I5. Now see, those current which is going towards the junction like I2, I1, I4, these currents are called input current, the current which is going towards the junction. I'll write here the current which is going towards the junction. The current which is going towards the junction is called input current. The current which is going towards the junction is called input current. Here see, I1 is going towards the junction, I2 is going towards the junction, I4 is going towards the junction. So if I am taking input current, example of input current, so it is like I2, I1 and I4. These three currents are said to be input current. Why input current, dear student? Because these currents are going towards the junction. Simple. Similarly, output current. So those current which is going away from the junction, is said to be output current. So I'll write here the current which is going away from the junction. The current which is going away from the junction is called output current. So remember this thing, my dear student, the current which is going away from the junction is said to be, dear student, output current. So let's check it out. Which current is output current? So away from the junction, it is I3, I5 and I6. So example of output current is I3, I5 and I6. These three currents are output current and these three currents are input current. Why these three currents are? Why I3, I5 and I6 are output current? Because these currents are going away from the junction. See the direction of arrow? It is away from the junction because this point is called junction. Now see what first law says. First law says the algebraic sum of input current, is always equal to this is the statement of first law, my dear student, Kirchhoff's first law. You have to remember this statement because this is very important for your board exam. So the algebraic sum of input current is always equal to the algebraic sum of output current. Algebraic sum of input current is always equal to the algebraic sum of output current. Why we are using the term algebraic sum? Because current is a scalar quantity. So we have to follow simple algebra to solve the values of current. So remember what first law says. As we know, first law is basically conservation of charge. First law is basically based on conservation of charge. So if charge is conserved, it means the input current, the current which is towards the amount of current which is going towards the junction is equals to the amount of current which is going away from the junction. So remember, the algebraic sum of input current is always equal to the algebraic sum of output current. This is basically Kirchhoff's first law says. So see which current is input current? It is I1, I2 and I4. So algebraic sum of input current means I1 plus I2 plus I4 is equals to I3 plus I5 plus I6. This is what first law says. Now see, the amount of current which is coming towards the junction is equal to the amount of current which is going away from the junction. So no current is left at the point called junction. I am repeating once again, the amount of current which is going towards the junction becomes equal to the amount of current which is going away from the junction. So we'll say no current is left at this junction, so charge is conserved. This is what actually first law says. In some books it can be write as I1 plus I2 plus I4 is equals to minus I3 minus I5, or let's take minus common, plus and I6. So this negative sign shows these currents direction is opposite to this current. The sum of this current, that is output current, is the direction of the direction of output current is opposite to the direction of input current. So this is what actually first law is. Remember, Kirchhoff's first law is nothing but the algebraic sum of input current is always equal to algebraic sum of output current. This is what first law is. Moving forward, my dear student, we'll discuss now Kirchhoff's second law. So write down Kirchhoff's second law. Kirchhoff's second law. So before understanding Kirchhoff's second law, we have to discuss first some of the sign convention which we used in Kirchhoff's second law. So write down, first of all, write down the heading Kirchhoff's second law. Kirchhoff's second law, and then we'll discuss about Kirchhoff's second law. So here comes Kirchhoff's second law. Now see what actually Kirchhoff's second law says. Try to understand, dear student. So Kirchhoff's second law is also called loop law. Kirchhoff's second law is also called loop law. Loop means, dear student, closed circuit. Loop means nothing but closed circuit. And what is the meaning of closed circuit? The circuit in which current is capable to flow. So I'll write the circuit in which current is able to flow is called closed circuit, and closed circuit is also called loop. So basically Kirchhoff's second law is nothing but loop law as well, my dear student. And what actually loop is? Loop is nothing but a closed circuit. So meaning of closed circuit is the circuit in which current is capable to flow. That circuit is called closed circuit. I'm repeating once again. What is closed circuit? The circuit in which current is capable to flow is called closed circuit. Moving forward, see, actually, to understand Kirchhoff's second law, first of all, we have to deal with some sign convention. So write down sign convention for Kirchhoff's second law. Very important, dear student. Very important. The sign convention is very important. So write down sign convention for Kirchhoff's second law. Sign convention for Kirchhoff's second law. So see, my dear student, we'll discuss sign convention of two different circuit elements. The term called circuit element. I am using a word called circuit elements. So circuit elements is nothing but the components, or we can say the devices which is used in circuit. So we'll discuss only two circuit elements. One is battery and other is resistor, because in our circuit, in this chapter, we'll encounter with only two circuit elements. One is battery and second is resistor. So I'll write here circuit element means battery and resistor. These two things are said to be circuit element, battery and resistor. So now see, my dear student, how we'll deal with sign convention before starting Kirchhoff's second law, because in Kirchhoff's second law we'll use these sign convention. So first we'll discuss the sign convention in case of battery. So write down case first we are discussing for battery, sign convention for battery. Now see, dear student, basically battery is made up of like this. In any battery, two terminals are there. One is your positive terminal, which is considered to be higher potential, and one is your negative terminal, which is considered to be lower potential. So I am repeating once again, battery carries two different terminals. One is positive terminal and other is negative terminal. Positive terminal is said to be of higher potential and negative terminal is said to be lower potential. Now see what actually sign convention for battery we are discussing. Let's suppose we have a circuit like this, and in this circuit one resistor and one battery is present. Here is your circuit, this is your electrical circuit in which a resistor and a battery is present. Now this circuit is a closed circuit, dear student. In this circuit current is capable to flow. So this is basically said to be closed circuit. This is basically a closed circuit. In this circuit we are capable to apply Kirchhoff's second law, because Kirchhoff's second law is basically also called as loop law. Loop means the circuit in which current is capable to flow. So every circuit in which current is capable to flow, the circuit is said to be closed circuit. Hence we'll apply second law on every such kind of circuit. So moving forward, see, there is a resistor which is connected in this circuit. There is a battery having potential V. In this circuit, let's suppose current is capable to flow. Now, my dear student, I am using a word, if we will move in circuit. I am repeating once again. I am using a word, I am using a sentence like, for solving the circuit, we can move in the circuit. For solving the circuit, we'll move in circuit. So if I'm moving in circuit, let's suppose battery comes in front of me. Or resistor comes in front of me. I am applying Kirchhoff's second law in this circuit, and let's suppose when I am applying Kirchhoff's second law, let's say battery or resistor is come in front of me. Then how we'll deal with battery or resistor while we are applying Kirchhoff's second law? So handling with battery or resistor, we must know the sign convention. How to deal with sign convention, it is very important. So sign convention of battery. So see my dear student, let's suppose the potential of battery is V and I am moving in battery from point A to point B. Let's suppose I am moving from point A to point B. I am moving from point A to point B. I am repeating once again, I am moving from point A to point B. See my dear student, this point A is connected with positive terminal of battery and point B is connected with negative terminal of battery. So if point A is connected with positive terminal of battery, it means A carry higher potential and B carry lower potential. A is connected with positive terminal of battery and B is connected with negative terminal of battery. So if A is connected with positive terminal of battery, it means A carry higher potential, and B is connected with negative terminal of battery, it means B carry lower potential. And let's suppose I am moving from point A to point B. So check it out, A is of higher potential, B is of lower potential. It means I am going from higher potential to lower potential. I am going from higher potential to lower potential. So if I am going from higher potential to lower potential, it means my potential is decreasing. In that case, I'll write minus V. Remember, if battery comes in front of us and we are applying Kirchhoff's second law, and if we are moving from positive terminal to negative terminal of battery, then we are moving from higher potential to lower potential. That means I am standing at higher potential but going towards lower potential. So I'll write minus V. Similarly, in second case, let's suppose this is battery plus minus V, this is A, this is B. We know that positive terminal carry higher potential and negative terminal carry lower potential. Now my dear student, let's suppose I'll go from point B to point A. Now check it out. B is connected with lower potential and A is connected with higher potential. It implies A carry high potential and B carry low potential, because B is connected with lower terminal and A is connected with higher terminal. I am going from B to A, that means lower potential to higher potential. So if this happen, then we'll write plus V. Why plus V, dear student? Because I am going from lower potential to higher potential, that is my potential is increasing because I am going from lower potential to higher potential. So this is all about sign convention of battery. If we'll move from positive to negative, we'll write minus V. If we'll move from negative to positive, we'll write plus V. Simple. Next is sign convention for resistor. So write down sign convention for resistor. Sign convention for resistor. Sign convention for resistor. So let's check it out, how to apply sign convention in case of resistor. In case of resistor, how to apply sign convention. Let's check it out. So dear student, sign convention for resistor. Write down sign convention for resistor. Sign convention for resistor. I am talking about sign convention for resistor. So let's see. Let's suppose we have a resistor and every resistor carry two different terminals, or we can say two different ends. Let's suppose the resistance of resistor is R, in which I current is flowing, and let's suppose the potential of point A is VA and potential of point B is VB. Now my dear student, remember this thing. Potential across the resistor, I am repeating once again, potential across the resistor is given by Ohm's law. Potential across the resistor is given by Ohm's law. Potential across the resistor is given by Ohm's law. Ohm says V is equals to IR, where V is potential difference across the resistor. V is potential difference across the resistor. I is current in the resistor, and R is nothing but resistance of the resistor. Resistance of the resistor, current in resistor, and potential difference across the resistor. Remember my dear student, if we have a resistor of resistance R in which I current is flowing, and across the resistor, let's suppose the potential is V, then by Ohm's law we'll write potential difference across the resistor is given by V is equals to IR. V is equals to IR. I am repeating once again, if there is a resistor of resistance R, across them potential difference is V in which I current is flowing, then potential difference across the resistor is given by V is equals to IR. V is potential difference across the resistor, I is current in the resistor, and R is resistance of the resistor. Now check it out how to give the sign convention in case of resistor. So my dear student, case 1 is, case 1, if we move along the direction of current, if we move along the direction of current, if we move along the direction of current, so check it out. Let's suppose this is a resistor of resistance R in which I current is flowing, and we are moving along the direction of flow of current. We are moving along the direction of flow of current. We are moving along the direction of flow of current. Now see my dear student, the direction of current is from A to B. It means A carry higher potential and B carry lower potential, because we know that the direction of flow of current is always, the direction of flow of current is always from higher potential to the lower potential, from higher potential to the lower potential. So see my dear student, this is a resistor of resistance R in which I current is flowing. This terminal is of higher potential, this terminal is of lower potential. In this resistor I current is flowing, and we are moving along the direction of current. So if current is moving from A to B, it means A carry higher potential, B carry lower potential, and we know that potential across the resistor is given by relation V is equals to IR. So see, current, flow of current and R direction is same. In that case we'll write, because see, A is of higher potential and B is of lower potential, we are moving from higher potential to lower potential. So our potential is decreasing. So if our potential is decreasing, then we know that we'll use minus sign. So in that case we'll write V is equals to minus IR. So remember my dear student, if you will move along the direction of current, then potential across the resistor. If you are moving along the direction of current, then potential difference across the resistor is given by V is equals to minus IR. This is basically the sign convention. Now second case, if we'll move opposite to direction of current. So second case is, if we move opposite to the direction of current. Second case is if will move opposite to the direction of current. If we will move opposite to the direction of current, I am writing here case 2. If we will move opposite to the direction of current. If we'll move opposite to the direction of current. Now see, this is a resistor of resistance R. This end carry potential VA, this end carry potential VB, and the current is flowing from A to B. So if current is flowing from A to B, it means A carry higher potential and B carry lower potential. Now see my dear student, the direction of current is from A to B and we are moving from B to A. So if current is from A to B and we are moving from B to A, it means we are going from lower potential to higher potential. So if we are going from lower potential to higher potential, it means our potential is increasing. In that case, we'll write V is equals to plus IR. Remember, V is equals to plus IR. If we'll move opposite to direction of current, then we'll write plus IR. If we'll move along the direction of current, then we'll write minus IR. If we'll move positive terminal of battery towards negative terminal of battery, we'll write minus V. If we'll move negative terminal to positive terminal of battery, we'll write plus V. I hope you all understand the sign convention. Now come to Kirchhoff's second law. So check it out, what actually Kirchhoff's second law says. So statement of, write down, statement of Kirchhoff's second law. 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 Let's discuss about statement of Kirchhoff's second law. So second law says, let's suppose we have a closed circuit like this. In this circuit, let's suppose 3 resistors are there and a battery is there. The potential of battery is, let's suppose, V. The resistance of this resistor is R1, R2 and R3. The current is flowing from always higher potential to lower potential. And remember, as charge is conserved, so the amount of current which is coming out from the battery is equal to the amount of current which is going towards the battery. This is again very important point, my dear student. Write down in form of note, the amount of current which is coming out from the battery, the amount of current which is coming out from the battery is equal to the amount of current which is coming out from the battery is equal to the amount of current which is going towards the battery. The amount of current which is coming out from the battery is equal to the amount of current which is going towards the battery. The amount of current which is coming out from the battery is equal to the amount of current which is going towards the battery. So see what actually Kirchhoff's second law says. So second law statement is the algebraic sum of potential difference. The algebraic sum of potential difference across every circuit element. The algebraic sum of potential difference across every circuit element in a closed circuit in a closed circuit. I am repeating once again, the algebraic sum of potential difference across every circuit element in a closed circuit. Closed circuit means the circuit in which current is capable to flow. So the algebraic sum of potential difference across every circuit element. Element means, my dear student, resistor or battery. So the algebraic sum of potential difference across every circuit element in a closed circuit must be equal to 0. The algebraic sum of, you have to remember this statement because this statement is very important, my dear student. You try to understand the concept because Kirchhoff's law is quite important. After completing Kirchhoff's law, whatsoever topic is, we have to follow Kirchhoff's law on that topic. So the second law says that the algebraic sum of input current, the algebraic sum of potential difference across every circuit element in a closed circuit must be equal to 0. The algebraic sum of potential difference across every circuit element in a closed circuit must be equal to 0. Now let's discuss what actually how to apply second law. So see, my dear student, for applying second law, I am writing here, for applying second law, the circuit must be closed. The circuit must be closed. That is current must flow on the circuit. It is very important, my dear student. You cannot apply Kirchhoff's second law if circuit is open. That is, if current is not flowing on the circuit, a closed circuit, then Kirchhoff's second law is not applicable. Now, next, second thing, for applying Kirchhoff's second law, we have to make a closed loop. Closed loop means path in the given circuit. We have to make, for apply Kirchhoff's second law, we have to make a closed loop. Closed loop means path in the given circuit. Next, write potential difference across every circuit element, write potential difference across every circuit element along with sign convention, what we'll already studied. Now see, I am applying here Kirchhoff's second law. Check it out how to apply Kirchhoff's second law with the sign convention. So check it out, my dear student. First thing, just see, either the circuit is closed or open. So the circuit is closed because in this circuit current is flowing. So current is flowing in this circuit. 3 resistors are there, R1, R2 and R3. There is a battery having potential V volt. We are applying now Kirchhoff's second law here. So for applying Kirchhoff's second law, first we have to make the loop. Loop means the path on which we are flowing. Now, my dear student, remember one thing. Once you will decided your path, then you cannot change in between the circuit. So let's consider the path is like this. That is, I am moving in this direction, then in this direction, then in this direction, then again come to the same point. So it becomes a closed loop. Now see, what actually second law says? Second law says the sum of potential difference across every circuit element in a closed circuit must be equal to 0. So potential difference across every circuit element in a closed circuit must be equal to 0. So check it out, dear student. I'm moving from this point, moving, we'll counter with R1. Now check it out, my direction, the direction of loop and the direction of current is same. So if direction of loop and direction of current is same, then I'll already show you what you have to write, minus IR. So I'll write here minus I, and instead of R we can write R1 because the resistance of resistor is R1. Moving forward, next we'll counter with R2. My direction and current direction for R2 is same, so again minus IR. So I'll write minus IR2. Moving forward, again I'll counter with a resistor of resistance R3 in which current and my direction is same, so again minus IR3. So moving forward, now check it out. Counter with negative terminal of battery and going towards positive terminal of battery. So we are going from lower potential to higher potential. So if we are going from lower potential to higher potential, it means potential is increasing. So I'll write plus V and come again at this point, so is equals to 0. This is basically Kirchhoff's second law application. Now take negative in this side, so what it will be? V is equals to IR1 plus IR2 plus IR3. Taking common I, what will get? R1 plus R2 plus R3. So the value of I is nothing but V by R1 plus R2 plus R3. So remember my dear student, I'll write in form of note. With the help of Kirchhoff's second law, with the help of Kirchhoff's second law, we have to make the equation of current. We have to make the equation of current. Remember, if you are applying Kirchhoff's second law in any circuit, then you have to write the equation of current. Basically, Kirchhoff's second law can make the equation of current. So this is all about, dear student, Kirchhoff's first law and Kirchhoff's second law. First law is basically current law. Second law is basically voltage law. First law says the algebraic sum of input current is always equals to algebraic sum of output current. Second law says the sum of potential difference across every circuit element in a closed circuit must be equal to, dear student, 0. So this is how we'll apply Kirchhoff's second law along with sign convention. If your direction and current direction is same, write it minus IR. If your direction and current direction is opposite, write it plus IR. So if I am moving like this, then answer must be same, dear student. Either you will move clockwise or you will move anti-clockwise. Answer must be same. So check it out. If I am moving like this, anti-clockwise. So check it out. I am moving from this point, plus to minus. It means higher to lower, potential is decreasing. I'll write minus V. Moving forward, now see, my direction and current direction is opposite. So if current and my direction is opposite, we'll write plus IR3. Again opposite, so what we'll write? Plus IR2 plus IR1 is equals to 0. Take negative this side, so IR3 plus IR2 plus IR1 is equals to V. So I becomes R1 plus R2 plus R3 is equals to V. So I is equals to V by R1 plus R2 plus R3. So what we'll see here? We'll see either you can take loop clockwise or anti-clockwise. Answer becomes same, dear student. So this is all about Kirchhoff's first law and Kirchhoff's second law. Moving forward, let's discuss our new topic called combination of resistors. So write down next topic, it is combination of resistors. Combination of resistors. Write down next topic. Next topic is combination of resistors. So the topic is combination of resistor. Writing here combination of resistors. combination of resistor. So dear student, in 10th class also you studied about this thing. Resistors can be combined in two different methods. Resistors can be combined in two different methods. First method of combination is series combination of resistor. First combination is series combination of resistor and second combination is parallel combination of resistor. So there are two different combinations of resistor, dear student. One is series combination of resistor and second is parallel combination of resistor. We have to discuss the series combination of resistor and parallel combination of resistor by two different laws. First we will discuss it by Ohm's law and second we will discuss it by Kirchhoff's law. So first we have to discuss what actually by Ohm's law. So write down series combination of resistor, series combination of resistor by Ohm's law, series combination of resistor by Ohm's law, series combination of resistor by Ohm's law. So see dear student, I'll write here series combination of resistor by Ohm's law. Series combination of resistor by Ohm's law. First of all, we have to discuss what actually series combination of resistor is. So if the resistors are connected, dear student, by end to end with each other, if resistors are connected, if resistors are connected end to end with each other, then the combination of resistor is said to be in series combination. First thing, dear student, remember, if the resistors are connected like this, let's suppose we have three resistors of resistance R1, R2 and R3. They are connected end to end with each other. Let's suppose V volt battery is connected across these resistors. Let's suppose this is R1, this is R2 and this is R3. Check it out. This point is A, this point is B, this point is C and this point is D. So if you are seeing all the ends of resistor are connected end to end. If the resistors are connected end to end with each other, then the formation of circuit by resistor is called series combination. Second most important thing is, one more thing is there, that in series combination no junction is formed in the circuit. So write down next point. In series combination of resistor, in series combination of resistor, series combination of resistor, in series combination of resistor, junction cannot form. Junction cannot form. Junction means meeting point of more than one wire. So check it out, my dear student. Here no junction is there. All the resistors are connected end to end with each other. So this combination of resistor is said to be in series combination. First resistor is connected with other end of resistor. Second resistor is connected with third end of resistor. So this is basically how we'll say series combination of resistor is. Next point, my dear student, in series combination, remember, very important point, in series combination of resistor, current across every resistor is same, because current until and unless cannot be distributed until and unless any junction can forms. at junction only, my dear student, current is distributing. Without the formation of junction, current cannot ever to be, we can say distributed. So I'll write here, in series combination of resistor, current across every resistor is same. Current across every resistor is same, but potential difference across every resistor is different. Potential difference across every resistor is different. So remember, my dear friends, in series combination, current across every resistor is same, but potential difference across every resistor is different. So see, if current is coming from this side, as we know that current always flow from higher potential to lower potential. So check it out, current is going like this. The amount of current which is coming out from the battery is always equals to the amount of current which is going towards the battery. So input current is always equals to, dear student, output current in case of battery. Now see, R1 carry I current, R2 carry I current, R3 carry again I current. So current across every resistor is same, but remember, my dear student, current cannot flow from one point to another point if potential between 2 points is same. Write down in form of note again. If potential difference across, write down in form of note, if potential difference across 2 points is same, if potential difference across if potential difference across 2 points is same, then current cannot able to flow. Full stop. Write down second point. To flow the current between 2 points, for flow of current between 2 points, there must be some potential difference. Across the points. So see, if you wish to flow the current, there must be some potential difference between all these points. So let's suppose potential difference between the R1 is V1, potential across R2 is V2, and potential across R3 is V3. But remember, my dear student, the total potential, or we can say the net potential of the circuit is always equals to potential of the battery. I'll write the net potential of the circuit. The net potential of the circuit is always equal to potential of the battery. The net potential of the circuit is always equal to potential of the battery. So see, the net potential can be write as V1 plus V2 plus V3 is equals to V, because potential of battery is V. R1, the potential across R1 is V1, potential across R2 is V2, potential across R3 is V3. So net potential must be equal to potential of the battery. So V1 plus V2 plus V3 is equals to, dear student, V. Moving forward, now I'll apply Ohm's law and find the value of V1, V2 and V3. Then we'll put in this formula, we'll get some values. So check it out. By Ohm's law, V is equals to IR. So let's find V1. So V1 means potential across R1, resistance is R1, current is I. So I'll write IR1. Similarly, V2 is current is I, resistance is R2. So we'll write IR2. Similarly, if I'm talking about third resistor, current is I, potential is V3. So V3 is equals to IR3. Now put all these value in the given equation. So what we'll get? We'll get V is equals to IR1 plus IR2 plus IR3. So what we'll get? V is equals to IR1 plus R2 plus R3. So V by I is equals to R1 plus R2 plus R3. Now we know that by Ohm's law, V is equals to IR. So V by I is equals to R. Now see my dear student, instead of V by R, we'll write R, but this is basically net resistance. So we'll write R net in series is R1 plus R2 plus R3. So this is the value of net resistance when the resistors are connected in series combination. R net is equals to R1 plus R2 plus R3. Moving forward, let's discuss next case, that is parallel combination of resistors. So write down parallel combination of resistor. 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 So when we'll say resistors are connected in parallel to each other. So our topic now is parallel combination of resistor. Parallel combination of resistor. So see my dear student, when resistors are connected in such a way that junction forms in circuit, then the combination is said to be parallel combination. Then the combination is said to be parallel combination of resistor. Then the combination is said to be parallel combination of resistor. So my dear student, remember, when the resistors are connected in such a manner that junction forms, then the combination of resistor is said to be parallel combination. Now see, very important point, in series combination, resistor across every potential across every resistor is different and current is same. In parallel combination, the current is different but potential is same. So we'll write here, in parallel combination of resistor, in parallel combination of resistor, potential across every resistor is same, but current across every resistor is different. But current across every resistor is different, my dear students. So remember this thing, in parallel combination, junction form, first thing. Second thing, in parallel combination, potential across every resistor is same, but current across every resistor is different. So check it out, what actually parallel combination is. So let's suppose we have three resistors of resistance R1, R2 and R3. There is a battery which is present. Let's suppose V volt battery is there, R1, R2 and R3. Now see my dear student, this point is called junction because three wires are moving from this point, 1, 2 and 3. So this is basically, this point is called junction. Now see, battery is there having potential V. We know that current can flow from higher potential to lower potential. Now my dear student, very important point. If current find any junction, then current distributed itself. I'll write in form of note, if current found any junction, if current found any junction, current distributed. So remember here current find junction, so current distributed. Let's suppose in R1 current is I1, in R2 current is I2, and in R3 current is I3. Now again we know that the amount of current which is coming out from the battery is always equals to amount of current which is going towards the battery, because current is basically flow of charge and charge is always conserved. Moving forward, check it out my dear student. Potential across every resistor is same. So potential across R1 is V, R2 is V, and R3 is also V. So see my dear student, in R1 current is I1, in R2 current is I2, and in R3 current is I3. This I1, I2 and I3 is basically extension of I. So we can write I is equals to I1 plus I2 plus I3. So by Ohm's law, let's find the value of I. As we know that Ohm's law says V is equals to IR. So I is equals to V by R. So for I1, we know that potential across every resistor is same and it is V. We'll consider it as V. So V by R1. Similarly, for I2 it is V by R2, and for I3 it is V by R3. Now what we'll do, we have to put all the three values of I1, I2 and I3 in this equation. So what we'll get? We will get the value as I is equals to V by R1 plus V by R2 plus V by R3. Now V can be taken as common. So 1 by R1 plus 1 by R2 plus 1 by R3. V comes down. So I by V is equals to 1 by R1 plus 1 by R2 plus 1 by R3. Now we know that V is equals to IR. So V by I is equals to R, but if take reciprocal, that means I by V, it becomes 1 by R. So see, I by V becomes 1 by R, and this is basically net resistance. So we can write it as 1 by R net is equals to 1 by R1 plus 1 by R2 plus 1 by R3. This is the value of net resistance in parallel combination by Ohm's law, dear student. So guys, in next class we'll discuss same thing but with Kirchhoff's law. So prepare Kirchhoff's law in proper manner, go ahead with sign convention so that you will comfortable in next lecture. So thank you so much my dear student for today. In next class we'll meet with new topics. Till then, stay happy, take care. Thank you so much.